When selecting a fuel source for an 85 kilowatt emergency generator, the primary contenders are diesel fuel and natural gas, each offering distinct advantages and disadvantages. Diesel fuel's pros include firstly, wide availability. Diesel fuel is readily accessible at most gas stations, simplifying refueling during emergencies. Secondly, long shelf life. Diesel fuel can be stored for up to 12 months without significant degradation, ensuring reliability during extended power outages. Thirdly, high energy density. Diesel fuel delivers more power per gallon compared to natural gas. Fourthly, compatibility. Diesel generators are generally compatible with various diesel fuel types, including biodiesel blends. However, diesel fuel also has cons, including firstly, higher emissions. Diesel fuel combustion produces more pollutants than natural gas, including particulate matter and nitrogen oxides. Secondly, odor. Diesel fuel possesses a strong, often unpleasant odor. Thirdly, freezing point. In cold climates, diesel fuel can freeze, necessitating preventative measures during winter. Fourthly, higher fuel costs. In some regions, diesel fuel may be more expensive than natural gas. Natural gas's pros include firstly, lower emissions. Natural gas combustion produces significantly fewer emissions than diesel fuel, making it a more environmentally friendly option. Secondly, lower fuel costs. Natural gas is often cheaper than diesel fuel, particularly in areas with abundant natural gas resources. Thirdly, abundant supply. Natural gas is a plentiful resource in many areas, ensuring a reliable supply during power outages. Fourthly, clean burning. Natural gas burns cleanly, generating little odor or smoke. Natural gas also has cons, including firstly, limited availability. Natural gas is not as widely available as diesel fuel, and the necessary infrastructure may not exist in all locations. Secondly, higher upfront costs. Natural gas generators typically cost more upfront due to the need for specialized equipment and piping. Thirdly, shorter shelf life. Natural gas stored in tanks has a shorter shelf life than diesel fuel. Fourthly, piping requirements. Natural gas generators require piping and connection to the gas main, which can pose logistical challenges in certain areas. The choice between diesel fuel and natural gas for an 85 kilowatt emergency generator hinges on several factors, including availability, fuel costs, environmental concerns, and site-specific requirements. Diesel fuel offers convenience and long-lasting power, while natural gas provides lower emissions and potentially lower fuel costs. Carefully weigh the trade-offs in availability, upfront costs, and shelf life to make the optimal decision. To further elaborate on diesel fuel, it is a refined petroleum product that is composed of hydrocarbons. The refining process involves separating crude oil into various fractions based on boiling points. Diesel fuel is heavier and oilier than gasoline. Its chemical formula varies depending on the specific composition, but it generally consists of alkanes, cyclocanes, and aromatic hydrocarbons. Diesel fuel is graded based on its cetane number, which measures its ignition quality. A higher cetane number indicates better ignition and smoother combustion. Diesel fuel also contains additives to improve its performance, such as detergents to keep fuel injectors clean, stabilizers to prevent oxidation, and anti-gel additives to prevent freezing in cold weather. Diesel engines operate on the principle of compression ignition. Air is drawn into the cylinder and compressed to a high pressure, which raises the temperature of the air. Diesel fuel is then injected into the cylinder, where it spontaneously ignites due to the high temperature and pressure. The combustion process drives the piston, which in turn rotates the crankshaft and produces power. Diesel engines are known for their high torque output, which makes them suitable for heavy-duty applications. However, they also produce more emissions than gasoline engines, including particulate matter, nitrogen oxides, and sulfur oxides. The particulate matter consists of soot particles that are formed during incomplete combustion. Nitrogen oxides are formed when nitrogen and oxygen in the air react at high temperatures. Sulfur oxides are formed when sulfur in the fuel reacts with oxygen. These emissions can contribute to air pollution and respiratory problems. To reduce emissions from diesel engines, manufacturers have developed various technologies such as diesel particulate filters, selective catalytic reduction systems, and exhaust gas recirculation systems. Diesel particulate filters trap soot particles and burn them off periodically. Selective catalytic reduction systems convert nitrogen oxides into nitrogen and water using a catalyst and a reducing agent. Exhaust gas recirculation systems recirculate some of the exhaust gas back into the intake manifold, which reduces the combustion temperature and lowers nitrogen oxide formation. Biodiesel is a renewable fuel made from vegetable oils, animal fats, or recycled greases. It can be used in diesel engines either in its pure form or as a blend with conventional diesel fuel. Biodiesel has several advantages over conventional diesel fuel, including firstly, it is renewable and sustainable. Secondly, it is biodegradable and non-toxic. Thirdly, it produces fewer emissions than conventional diesel fuel. Fourthly, it can improve engine lubrication and reduce wear. However, biodiesel also has some disadvantages, including firstly, it can have a lower energy content than conventional diesel fuel. Secondly, it can be more expensive than conventional diesel fuel. Thirdly, it can cause problems with fuel system components, especially in older vehicles. Fourthly, it can gel in cold weather. Natural gas is a naturally occurring hydrocarbon gas mixture consisting primarily of methane, but typically includes varying amounts of other higher alkanes and sometimes a small percentage of carbon dioxide, nitrogen, hydrogen sulfide, or helium. It is formed when layers of decomposing plant and animal matter are subjected to intense heat and pressure over millions of years. Natural gas is extracted from underground reservoirs through wells. The gas is then processed to remove impurities and separated into its components. Methane is the main component of natural gas and is used as a fuel for heating, cooking, and electricity generation. Other components such as ethane, propane, and butane are used as feedstocks for the petrochemical industry. Natural gas is transported through pipelines to distribution centers, where it is then delivered to homes and businesses. It can also be liquefied by cooling it to a very low temperature. Liquefied natural gas, or LNG, is much more compact than gaseous natural gas and can be transported by tankers to locations that are not connected to pipelines. Natural gas is a relatively clean-burning fuel that produces fewer emissions than coal or oil. However, it is still a fossil fuel and contributes to greenhouse gas emissions. Methane, the main component of natural gas, is a potent greenhouse gas that has a much higher global warming potential than carbon dioxide over a shorter period. To reduce methane emissions from natural gas production and distribution, companies are implementing various measures, such as improving leak detection and repair programs, using advanced technologies to capture methane from venting and flaring, and replacing older equipment with more efficient models. Renewable natural gas, or RNG, is a biogas that has been upgraded to meet natural gas pipeline quality standards. Biogas is produced from the anaerobic digestion of organic matter, such as food waste, agricultural waste, and wastewater sludge. The biogas is then cleaned and purified to remove impurities and increase its methane content. RNG can be used interchangeably with conventional natural gas and can be transported through existing pipelines. RNG is a carbon-neutral fuel because the carbon dioxide released during combustion is offset by the carbon dioxide absorbed by the organic matter during its growth. In addition to being used as a fuel for heating, cooking, and electricity generation, natural gas can also be used as a transportation fuel. Compressed natural gas, or CNG, is natural gas that has been compressed to less than 1% of its volume at standard atmospheric pressure. CNG vehicles have a dedicated fuel tank and engine modifications to run on natural gas. CNG is a cleaner burning fuel than gasoline or diesel and can reduce emissions of greenhouse gases and air pollutants. However, CNG vehicles have a shorter range than gasoline or diesel vehicles and require a network of CNG refueling stations. Liquefied natural gas, or LNG, can also be used as a transportation fuel, especially for heavy-duty vehicles such as trucks and buses. LNG vehicles have a cryogenic fuel tank that keeps the natural gas in a liquid state. LNG has a higher energy density than CNG, which allows for a longer driving range. However, LNG vehicles are more expensive than CNG vehicles and require specialized refueling infrastructure. When evaluating the use of natural gas for an 85 kilowatt emergency generator, consider the following factors. Firstly, the availability of a natural gas supply. If the site is not connected to a natural gas pipeline, the cost of extending the pipeline can be prohibitive. Secondly, the reliability of the natural gas supply. Natural gas pipelines are generally reliable, but outages can occur due to maintenance or emergencies. Thirdly, the cost of natural gas. Natural gas prices can fluctuate depending on market conditions. Fourthly, the environmental regulations. Some areas may have restrictions on the use of diesel generators due to air quality concerns. Fifthly, the space requirements. Natural gas generators may require more space than diesel generators due to the need for piping and other equipment. Sixthly, the permitting requirements. Installing a natural gas generator may require permits from local authorities. Another consideration is the maintenance requirements of each type of generator. Diesel generators require regular maintenance, such as oil changes, filter replacements, and fuel system cleaning. Natural gas generators also require regular maintenance, such as spark plug replacements, air filter cleaning, and valve adjustments. The maintenance costs for each type of generator can vary depending on the model and the operating conditions. It is important to factor in these costs when evaluating the overall cost of ownership. To summarize, the choice between diesel fuel and natural gas for an 85 kilowatt emergency generator involves weighing the pros and cons of each fuel source. Diesel fuel offers wide availability and long shelf life, but produces higher emissions and can be more expensive. Natural gas offers lower emissions and potentially lower fuel costs, but may not be as readily available and requires specialized equipment and piping. Consider the specific requirements of the site and the priorities of the owner when making the decision. If the primary concern is reliability and availability, diesel fuel may be the better choice. If the primary concern is environmental impact and cost, natural gas may be the better choice. Ultimately, the best choice depends on a careful evaluation of all the factors involved. The emergency generator size of 85 kilowatts is appropriate for a variety of applications, including small businesses, data centers, and residential complexes. The generator should be sized to meet the critical load requirements of the facility. The critical load is the amount of power needed to keep essential equipment running during a power outage. This may include lighting, computers, servers, and medical equipment. The generator should also have sufficient capacity to handle any additional loads that may be required during an emergency, such as air conditioning or heating. It is important to consult with a qualified electrical engineer to determine the appropriate size and type of generator for a specific application. The engineer can perform a load analysis to determine the critical load requirements and can recommend a generator that meets those requirements. The engineer can also help with the installation and commissioning of the generator. The installation of an emergency generator must comply with all applicable codes and regulations. This may include the National Electrical Code, the local building code, and any environmental regulations. The generator must be installed in a well-ventilated area and must be protected from the elements. The generator must also be connected to a transfer switch, which automatically switches the load from the utility power to the generator power during a power outage. The transfer switch must be properly sized and installed to ensure safe and reliable operation. The emergency generator should be tested regularly to ensure that it is working properly. The testing should include starting the generator, running it under load, and checking the voltage and frequency. The testing should also include checking the transfer switch to ensure that it is switching properly. The results of the testing should be documented and kept on file. The emergency generator should be maintained in accordance with the manufacturer's recommendations. This may include changing the oil, replacing the filters, and cleaning the fuel system. The maintenance should be performed by a qualified technician. The maintenance records should be kept on file. In summary, selecting and installing an 85 kilowatt emergency generator requires careful planning and attention to detail. The generator should be sized to meet the critical load requirements of the facility. The installation must comply with all applicable codes and regulations. The generator should be tested regularly and maintained in accordance with the manufacturer's recommendations. By following these steps, you can ensure that the emergency generator will provide reliable backup power during a power outage.